Do you like living in Portland?
I don't live in Portland directly, but yeah, I like Oregon a lot. It's
Okay.
For an American place to live, it's pretty good.
So I know I read one of your tweets where you said you were going to go back to Canada or something. Is that true?
Yeah. I'm planning to head to Canada. And the United States has just gotten a little crazy. Well, I've been here for a long time,
right?
And there are lots of reasons, but it's just I like change. I move every 10 years as well.
Oh, every 10 years.
Yeah, about that.
Yeah. What other places have you lived at?
Well, I've lived in Arizona and Ohio, but in Australia, Arizona, Ohio, Connecticut, Massachusetts.
Okay.
I was sort of 8 or 9 years in Boston when I was at graduate school, and then at Harvard after that. And then
nice.
I taught at Yale for a little over 8 years, and then Ohio. Then I was chair of the physics department in Ohio. I just find the change is invigorating. It
is. All right. So, what inspired you to write The Physics of Climate Change?
Well, first of all, I have to say part of it was the pandemic. Okay. I normally travel and lecture and go back and forth to places, and here I was not, at home, not doing anything, and I thought, what can I do? And I started, and really what had motivated me is I'd taken a group earlier in January to the Mekong Delta for many reasons, and I began to research climate change in the context of that, and that really grew on me. And speaking to that group, their reactions really indicated to me that people really wanted to understand what it was about, or some people did.
Right.
But the importance of understanding and how could one frame it in a way that was accessible, because it seemed to me it's become such a political issue. But basically, if you can't discuss the science in some easy and accessible way, then how can you expect to have any rational public debate?
Exactly.
And the idea really grew on me, and I wrote with a frenzy, and it was fascinating for me to I like to learn new things in the context, but it was trying to understand, sort of like I did, and the reason the title is The Physics of Climate Change is, in some sense, harkens back to my book 25 years ago, The Physics of Star Trek, where I tried to take a subject that was, sort of in some ways really seemed inaccessible and make it accessible, and latch on to something that was, in that case, a cultural symbol. In this case, climate change is a vital question. But what I wanted to do was write a book that wasn't about policy.
Okay.
I wanted to write a book that hopefully would reach people who were skeptical, who didn't were worried about policies that might infringe on their pocketbooks or something else, and so I didn't want to write a book that advocated policy, because that would turn those people off.
Exactly.
And I was very, very happy after I finished it and I wrote it, I have to say, in a normal book takes me at least a year to write, and this would have taken me at least 10 months. I wrote it in 10 weeks because I basically morning, noon, and night, and it was kind of a new experience for me. I'd never done anything like that. I also wrote it before I'd had any arrangement with a publisher, which is also the first time I'd ever done that with any of my books. But it was a subject that clearly had captured me.
Exactly.
And I was very happy afterwards when I had colleagues or friends who were somewhat skeptical, who weren't scientists, who read it and said, this is the book I've been looking for.
And on that topic, how would you describe the physics of climate change to a layman?
Well, that's what the book's about. But I guess the point is that the key thing I wanted to demonstrate was that you hear all this stuff about complicated computer models, supercomputer calculations of climate, and that's true. To do refined estimates of what might happen in some location, or how precipitation could change in the northern hemisphere versus the southern hemisphere, and specifics of melting of glaciers, but the fundamental physics, as I like to say in the book, is it isn't rocket science. It's based on really basic physics that is understandable. Obviously, one hears the term the greenhouse effect, but and that's a key notion, but it's often again misplaced. But so what I wanted to do was describe, and what I can do is describe the fact that it's just although there are differences, it's like thinking what happens when you sleep under a blanket on a bed, okay? Your body's radiating heat, and it would radiate out, okay? The blanket, in some sense, stops it from radiating out, and that's what people often think of as greenhouse effect. But it's even more subtle than that. The point is that by the blanket basically absorbing your heat and radiating it back to you,
Okay.
the surface of the blanket is cooler than the surface of your body.
Right.
So the surface of the blanket is radiating, as all things are, but at a lower temperature, and therefore less radiation is going into the room. That's the key of the greenhouse effect that I think most people don't realize. It's really not what's happening at the surface of the Earth. It's as the atmosphere absorbs more infrared radiation from the Earth's surface.
Right.
Let me step back.
Okay.
The sun heats the Earth. Okay. It provides energy that impinges on the Earth each day, and the Earth reflects some of it. Okay. And it absorbs some of it and it re-radiates some of it.
Okay.
Now, if it didn't radiate into space the same amount of radiation that came in from the sun, then the Earth would continually heat up.
Right.
So in equilibrium, it's got to radiate into space the same amount of energy that comes in from the sun.
Right.
And where does it radiate? It radiates from some of it, gets reflected from the surface of the Earth and goes through the atmosphere. But the radiation coming from the Earth is radiated from the surface of the atmosphere, the edge of space, because that's where the radiation can escape into space.
Okay.
And if we absorb more radiation in the atmosphere, then the point where the Earth radiates into space is at a higher elevation, because the atmosphere isn't transparent until you're higher up, because radiation is being absorbed. And higher up, the atmosphere is cooler. So effectively, the Earth is radiating into space from a cooler place, which means it's radiating less energy, which means it's heating up, because it's getting in. And what happens is it heats up enough until eventually you get an equilibrium again. That's something called radiative forcing, and that's the sort of what I've given here is a basic explanation of that. But that's the heart of what's happening, of the heart of the reason that carbon dioxide and other greenhouse gases are important, even with very small percentage in the atmosphere, is they change the point in the atmosphere, at the upper level of the atmosphere where the Earth radiates. That's basically the heart of it. And the interesting thing is that the science of it is quite fascinating. The history of it is quite fascinating, as I discussed there.
Mm. And if we were to take actions to stop climate change, do you think it's too far gone, or do you think we could still?
It's never too far gone to take action. I mean, that's the point. Look, there are things that are going to happen, as I discussed in the book. Like it or not, given the heat energy that's already been absorbed due to the fact that we've increased the carbon dioxide abundance in our atmosphere by 30% since 1900, more or less.
30%. Wow.
30%. Yeah. Well, actually, since the measurements first started to be taken about 1960.
Okay.
By Ralph Keeling, when the carbon dioxide abundance was at something like 315 parts per million. That's in 1960. It's already up to 420.
Wow.
It's changing on a short time scale, in 60 years, by that incredible amount.
That's a lot.
And that's a lot. And the question is, well, when you say it's a lot, and one of the things I try and do in the book is, what is it? Is it a lot? What does it mean to have changed?
Exactly.
It's still less than 1 part in 10,000 of the atmosphere.
Right.
Or 4 parts in 10,000, I should say, in the atmosphere. But so the point is that there are things we've already done, and that they're not model dependent, and that's the other thing that's important. Really, what I want to show is, the fine details are model dependent. It's like the fine details of designing a car, a fancy sports car. You have to really work and do literally fancy computer models, but how an internal combustion engine works, you don't need fancy computer models to understand. Exactly. And so, anyway, for example, the sea levels are rising, and much of the conventional wisdom is that sea levels are rising because somehow glaciers are melting but in fact, a fair fraction, at least half of the reason sea levels rising, is a simple fact of physics. When you heat water up, it expands.
Right.
And the oceans have stored a lot of energy that's heat energy that's being circulated around the oceans. And just from the heat we've already dumped in, even if we stopped using fossil fuels and brought the level down today to where it was in 1960, even if we stopped that, you're talking by the year 2100 and about a quarter of a meter, 25 centimeters of sea level rise. That may not seem like a lot.
That's a lot.
But it is a lot, as I talk about near the end of the book. In places around the world, that alone is significant. And so that's going to happen.
Right.
And so, first of all, when we think about action, the worst thing we can do is put our heads in the sand and say, I don't want to think about the problem.
Right.
because we should at least prepare for that. Okay, and that's not going to end civilization, but it's going to produce known effects, and we should be prepared for that in the first world countries where we can imagine what's the effect of and in fact, if you plug in all the other effects that are likely by 2100, we're probably going to have 1 meter sea level rise.
Wow.
That's more or less a conservative number, and it's more or less independent of whatever we do. Okay.
So if you were president of the world and you would and you would have to pass executive orders to stop this, what would be?
Well, the point is that there's a lot we can't stop, but we can try and ameliorate. We can try and look at low-lying regions and ask what can we do to protect them. That's not unheard of. Think of Holland. Much of the country is already under sea level.
It is,
but
yeah.
But they managed to build incredible systems that protect that country. There'll be, as I discussed in the book, where I was, most of South Vietnam, almost all of South Vietnam will be below sea level by 2100. In fact, by 2050 probably. And all of that.
How would you stop that?
Well, there you'd have to imagine incredible engineering feats with sluices and gates, and
right.
And you also have to imagine the things that are exacerbating that as well, because that whole region depends on the Mekong Delta basically flooding the rice fields at various times of the year. And the Mekong Delta, as I said at the very beginning of the book, what amazed me, if you go down the Mekong River, you see these barges dredging sand everywhere. The sea level, the river level has has dropped by over 1 meter due to sea level, due to dredging for sand, for concrete, and things like that. So you got to say, how can we first of all stop making the problem worse? And then you'd have to imagine huge construction projects. You also might have to imagine saying, well, maybe we can't do that. How can we adjust our economy? How can we consider relocating people? Because there'll be, and that's another problem. Unfortunately, if you look at the predictions differentially of what are likely around the globe, you find that the effects are probably exacerbated more or less around the equator, okay, or near equator, but near regions which are unfortunately both impoverished. Many countries are impoverished and largely agricultural, and that's going to have a huge impact
on their agriculture.
And so today there's a big issue of immigration in this country and other countries, but we have to prepare for the fact that they're already climate migrants, but there are likely to be many more climate migrants, people who literally their livelihood depends on agriculture, but the climate has changed,
right,
or the conditions have changed the way that they can't function anymore, and they're going to move.
Right.
And so if we're not prepared for that in advance, we're going to have an influx of not just tens of thousands or millions, but if you look at it, there's something like 120 million people on Earth who live in regions that are low-lying enough to be affected by the turn of the century. Right. But the other thing is, clearly...
But why are people so skeptical? Like,
yeah, that's a good question. I mean, people...
everything you just said makes complete sense to me. But
I think people are skeptical, first of all, because they don't want to... People are worried about their livelihoods, okay?
Right.
Some people are worried about the lives in the future, but some people worry that if we enact changes that'll impact on this, that'll affect the standard of living,
right,
and what people say, oh, you can't, use fossil fuels, you can't drive your cars, and that's right, just not the case. What we need to realize is that, and I think this is why I try and end the book in some sense on not necessarily an optimistic note, but it's like the Dickens story of the Christmas Carol. There's the future as it might be.
Right.
And if we picture the future as might be, we can change the future now by taking action. And there are and technology is a remarkable thing. And so the problem really isn't a technological one, it's a political one. There are lots of things we can do to try and address the problem, including investing in technologies that reduce our dependence on fossil fuels in a way that doesn't hurt the standard of living, actually helps the standard of living. And I think a lot of the skepticism is unfortunately due to short-term greed.
Greed, really.
Basically, that and the funny thing is, many fossil fuel companies, just like the if you look at the groups that are already looking at the future and seeing what it's going to be, those include fossil fuel companies. They see the writing on the wall. Right. As does the U.S. military, by the way. One of the first organizations that created a study group on climate change was the military. Why? Because it's their job not to worry about what the politicians say or what is politically correct, but what are the real threats in the 21st century. And in some sense, climate change is a national security threat. I think there's been a very effective public relations campaign against the notion of climate change for two reasons. One is the greed aspect, but the other is that
people don't want to do something now for something in the future.
Well, that's always the case. It's very hard to imagine something in, your grandchildren. In fact, by talking about grandchildren, maybe one of the few ways we could try and reach people. But it's not a problem like nuclear weapons where the world will end today. Okay, and let me state again. I'm not saying the world's going to end. It's just going to be dramatic changes that we're going to have to address. I think also the problem is a skepticism. There is unfortunately a growing skepticism about various kinds of science. You're seeing it in the pandemic. People who saying, I don't trust the scientists. But somehow what people were able to do is focus on this model aspect. And it is absolutely true that the detailed climate models are incredibly complex, and some of the predictions have large uncertainties. And one of the biggest misunderstandings in the public today is the notion of uncertainty in science. Like uncertainty is a bad thing. In fact, it's a good thing. Science is the only area of human intellectual activity where we can quantify our uncertainties. We can say, here's our prediction, but there are these error bars. And that's incredibly important. It's central in all the physics I do, from cosmology to particle physics. Being able to quantify our uncertainty is incredibly important. But the fact that models have uncertainties and the fact that they're complicated is something that people can harp on. And what you get is people saying, I disagree with this model because they haven't put in this factor. It's a complicated computer.
Well, even think to recently, like with the models of the coronavirus. They said these models said certain things are going to happen. At the end, they realized they weren't going to happen. So that kind of adds to the skepticism.
Well, it does in a sense, but what it does is people, sometimes the scientists are sometimes to blame for this. If you overstate what your predictions are without your uncertainties, then it comes around and bites you in the butt. And one of the biggest things about the pandemic and the coronavirus is that people don't realize that epidemiology is an incredibly complex and uncertain field because the statistics are so bad. You can't predict what a virus is going to do. There's no way during a pandemic you can make accurate predictions of what's going to happen when you don't know many features. And so the scientists do the best they can, but to assume partly, I was just on a program about Star Trek the other day, and I was saying one of the things that Star Trek did that hurt us is gave the illusion that when there's this technical problem that Geordi or someone else can or Scotty can fix it in an hour. That technologically we'll go and do it. And the point is that's not the way it works in the real world. It takes a long time, and if you and garbage in, garbage out. If you don't have the data, if you don't have the experiments that give you precise understanding of many features, in the case of the pandemic, like transmission and the dynamics of how of what the virus does, you can't possibly make really accurate predictions. What you can do is say, if this, then that. And that's what I think the accurate epidemiologists were trying to do, but people, of course, latched on to either the worst case predictions or the best case predictions.
It reminds me of kind of like when I work with clients. I'm a software engineer. I've worked with Google and Cisco and the whole deal. And when you're trying to explain to a client or a stakeholder that they can't do something technologically speaking because you need to get other assets. They don't understand that. It's all like a difficult job or to explain complexity sometimes.
I think the hardest thing is when people want a result. It's really hard to understand. Some people in the pandemic want a result would be no deaths. Some people want it a lot so that they would hurt politicians or so that people would be shocked. And I think it's the same. People obviously look at the climate change is such a slow process. It's kind of like evolution. There are all these, for a long time I spent a lot of my time trying to convince schools not to stop teaching evolution, which is the base of modern biology. But evolution involves change.
I thought you were a promoter of creationism.
Yeah, sure. And but one of the problems with that is that though evolutionary processes happen over long time periods that are so long that when people look around, then they'd say to me, I don't see species changing today, and it's a slow process. And climate change is a slow process. It's not that slow. I mean, what amazed me in the writing of the book, and I already knew some of it, is how dramatic various changes have happened. And that's the other important thing. People suggest that the problem with climate change is its predictions of the future. In fact, it's happening now, and you can measure it now. It's not some model-dependent theoretical prediction of scientists that you may not trust.
Right.
You can measure things, certain things like the acidification of the ocean, which is a direct consequence of the increase in carbon dioxide in the atmosphere. There are many changes you can. In fact, one of the more interesting things that I discuss in the book, which is remarkable, is there's a difference between weather and climate. Okay. And weather is what's going to happen at a location, today or tomorrow, and climate is sort of global conditions that change over time that can be measured. And what's really interesting is, for the first time, a Nature article came out suggesting that in weather measurements, namely around the world on a given day, you can actually see the effect of climate change for the first time statistically. It's really hard to distinguish weather from climate, and I talk about that. So, in fact, in certain cases, things are actually measurably changing on a time scale that is not the scale of our children or grandchildren. And
so why isn't it called weather change instead of climate change?
Well, no, because it isn't weather change. Okay. Weather is, the weather tomorrow, and this is a real problem. When a senator from Oklahoma brings in a snowball from Washington saying today was a really cold day in Washington, therefore the climate isn't changing.
Right.
Weather varies by a great amount on any location. Today, we're doing this interview in Portland, in Oregon, and I can tell you the weather changes a lot here. Happily, it's a sunny day, but
what do you say to those who say everything you say makes complete sense, but now is it humans' fault? That's where they diverge.
Well, again, and the whole point is to try and look at that, and that was the question that was asked early on when people were measuring carbon dioxide. And there's an old saying, if it walks like a duck and quacks like a duck.
Right.
And so the point is, we can measure how much carbon dioxide humans are putting in the atmosphere by human industrial activity.
You can. Okay.
Yeah, we can measure it. Okay. We then determine how much there is, and then we look and we see, well, the amount by which carbon dioxide in the atmosphere is increasing in a way that's exactly explicable to.
Is that just humans or all animal life?
No, human industrial activity.
I see.
Yeah, and we can see that the amount it's changing is completely consistent. Now you could say maybe there's a vast conspiracy,
right.
but you can also say, well, but is that changing the climate? And you could say, well, let's make some basic, simple predictions. If you increase carbon dioxide by this amount, what it will do for global, say, temperatures. Well, what do you know? The global temperatures has changed by 1 degree C, which is more or less exactly what you'd predict for that increase in carbon dioxide.
Right.
So you can say, well, every prediction is bang on with the observations, and the observations are consistent with what we're arguing, and maybe there's some vast conspiracy that of effects that somehow everything we predict is wrong, but something else is producing exactly what we predict. And you could say, well, that's always possible in science. Maybe gravity doesn't, go as 1 over r squared. Maybe they're little pink elephants that are sneaking in when I drop a ball and pushing it down. I mean, I can make all that, but the simplest argument is that the simple predictions work and are measured to be consistent with the observations. And in the case of climate change, everything is consistent with human industrial activity, and there's no, and this is the key point, there's no alternative explanation.
What about the climate on Mars? Why does it change so often? Especially, Mars is just coming out of an ice age.
We were too, okay? But that happens on that happens on geological time frames. On the time frame of 30 years, nothing can explain or let's say 60 years since Ralph Keeling first started to measure the increased climate. On that time scale, nothing can explain the effects that are observed except for the fact that we're dumping carbon dioxide in, and it's producing that effect. The Earth has gone through many climate changes, and we can measure them. And people say, well, with the Earth, but once again, in the first case, one can describe the astrophysical and geological reasons or connections, correlations between long-term climate change and glacial periods, and what we see in the Earth. Those are generally explicable, but they're not. The sun isn't changing in its emissivity and its luminosity on a time scale of 60 years in a way. I mean, the sun is changing, and the Earth is. There's no doubt that
a longer, gradual kind of.
Oh yeah, the sun in 2 billion years, the sun will be 15% brighter, and then, by the way, there will be a global runaway greenhouse effect where the surface of the Earth will be like Venus, but unless we do something about it.
Unless we go to Mars,
or unless we do something. We're an intelligent species sometimes.
Put like a huge softbox over?
There's lots of things we might imagine. We might move the position of the Earth. Yeah, there's lots of but that, I think that 2 billion year change is not something we need to worry about right away.
Right.
We have 2 billion years if we're around, and that's not So the point is that. You're right that the weather changes, and that's the key thing to distinguishing weather and climate.
Okay.
And because people, that's another thing I think that's really important to understand, that when it comes to people's skepticism, people say, well, look, I can predict the weather here in Portland tomorrow, and I can make a prediction a week from now, but my prediction is not likely to be right. Well, if I can't predict the weather in Portland a week from now, how can I predict climate?
That's a good point.
And it's a very different thing. You're not talking about local variability. In this week, you're talking about a global effect, but also you're talking about averaged over many individual variations, which are you're averaging over many individual That's why, for example, I might not be able to predict what you can do, but if I take all of humanity, I can make certain predictions because what the law of large numbers, where the average of humanity will do something. Okay, the average height of humans will change, the average population will grow.
Generally speaking, exceptions excluded, essentially.
Well, yeah, absolutely. But that's one of the reasons I do cosmology. I often say is that the universe is far simpler to understand because there's lots of complexity here on Earth.
Right.
And one of the reasons I don't do climate change as a scientist is so complicated compared to cosmology. In that sense. Well, it's not the only reason. I'm interested in sort of fundamental questions of how the universe works, but the universe is relatively easy to understand, because it's so simple on large scales, in spite of the all the local variability.
Right.
And climate, because we're averaging over local variations, and we're looking at longer time scales, is in some sense easier to understand. Because you're looking at global quantities like the emissivity of the Earth, the absorption of radiation, global effects. As I say, it's not rocket science to say the Earth has to radiate into space the same amount of radiation that comes in for the sun, or it'll heat up. I don't think anyone can deny that fact. Okay, and if they do, then they're denying basic physics.
Exactly.
Okay, if what goes out is the same as what comes in, everything's going to remain the same.
Right.
And if it changes, things will change. And so, if you look at global questions such as radiation by the Earth, and we can measure, by the way, again, these aren't model-dependent things. In my book, I have graphs showing satellites measuring the emissivity of the Earth in different bands, and you can see. So we can look at the radiation emitted by the Earth, and we can look at the radiation coming down in the Earth. And so these aren't. This isn't.
Do you think people should be educated on this from elementary school to?
Well, basic.
Should it be like a required curriculum?
Well, look, I think the required curriculum should be to understand how we understand things, and how to separate sense from nonsense. It used to be the school taught kids facts, okay? Right. But now, as I often say, there's more facts in my iPhone than anything. But there's more misfacts. What we have to teach people is how to question, is the scientific method.
Right.
That's what we need to teach people, to rely on empirical evidence, many different sources, to question yourself, question others, test your hypotheses, and that sort of thing. Now, but when it comes to basic things about climate change, absolutely. It's a great example of how to ask questions about the world and how to look at things, which is why I wrote this book. It's the kind of thing that anyone should, at some, I'm not asking everyone to be a climatologist, and people say that, I just recently wrote that I was very upset at the Supreme Court candidate who happened, while we're talking, is maybe confirmed, and it'll date when we're talking about this, but when she was asked about climate change, she read about it, but she didn't have any strong views. And then when she was asked about in the context of whether she believed smoking causes cancer, she said she didn't want to discuss the issue because it was politically controversial. Well, science isn't politically. Science is science.
Right.
And so arguing that I refuse to discuss reality because it might impact on politics is a problem. But anyone who considers themselves literate should at least have a basic understanding of the very issue that I just said. Energy in equals energy out. Certain basic concepts of science that are essential for everyday life. I think what I think is we need scientific literacy at the same way we need literacy in other things. History. We expect people to know the Holocaust happened. Okay, I mean basic aspects of history, or how to determine what happened in the Second World War. We expect people to know maybe who William Shakespeare was if they have some literacy.
Right.
And so having some basic understanding of energetics and science is important. But we've removed ourselves from that responsibility. We've hidden from that responsibility. People can proudly claim their scientific illiteracy, and it's a badge of honor. Whereas it would disqualify them if they said, well, I think I've heard who Shakespeare was, but I have no strong views on. I mean, people would laugh at them.
Right.
But we somehow decide that to understand any aspects of science, you have to be a scientist.
Right.
But we don't say that about anything else. To understand any basic aspects of economics, you have to be an economist.
Why do you think that is? Why do you think people put such a high kind of bar?
I think part of it is the scientific community themselves, right? It's very, if you claim to have a secret knowledge,
right,
it gives you power, right?
Right.
And I think that kind of elitism, I think, is a good part of it. But part of it also, I think, is that just partly science relates to math.
Okay.
And people are afraid of mathematics. And we, again, don't convince people that most people can do basic mathematics. If people say, gee whiz, numbers don't do anything for me, we say, okay, fine. But again, once again, if people said, English writing doesn't do anything for me, they wouldn't get a job.
Exactly.
Okay. And so I think it's just that it seemed cool for too long. I mean, we talk about the poor science education in schools, and there has been, okay? But what worries me almost as much, having taught at Yale for many years, was seeing kids who were clearly intelligent,
right,
but we gave them a free pass. They could proudly proclaim their scientific literacy and call that culture. Somehow saying...
my point. I was going to make that point, actually. What do you think about universities now not being so picky about the people that go into school?
Well,
I mean, the thing is, when you're not as picky with people, then you have to kind of dumb down the curriculum so it could be learned by someone who might not otherwise be able to learn something like that.
Well, I think that I'm more optimistic. I think most people. That's why I write popular books, among other things. I think basic ideas anyone can access. So I'm not. I am concerned that universities, first of all, and one of the reasons I was frustrated at Yale is they give the impression that students don't have to understand any science to be cultured, and moreover, in some sense, the less they understand or the less capable they are dealing with it, the more cultured they are. That somehow saying math doesn't work for me is akin to saying, yes, I'm an artistic person.
I'm a more creative person, right?
Yeah, exactly, and that's just not true.
I've never understood that. Yeah.
Yeah, no. Well, but it's a myth.
Right.
A friend of mine, Alan Alda, who's an actor, once said, he's done a lot to promote science, and we've done a bunch of events together. But I love what he once said. He said he talked about science versus the arts, and he said, science requires creativity and the arts require hard work, or something like that. Just to, and it's true. It's but they're both very similar in requiring creativity and hard work. But when it comes to universities, again, I think that what is a problem more for me of a problem with universities is, I think for many people...
And people don't want to talk about that usually.
Yeah, well...
Because they want to make education accessible to everyone.
Well, education should be accessible to everyone, but that doesn't mean everyone should go to university.
Exactly.
And having taught at universities for many years and had a daughter who went to college and a stepdaughter who's now in college, it's clear to me that a lot of kids go to university without knowing why they're there. There are a lot of countries, I guess when I lived in Switzerland for a little while when I was working at CERN, and which is a scientific establishment in Geneva. And what surprised me, and I've spent a lot of time in Zurich, is to learn that in Switzerland they generally tend to steer kids so only 15% go to universities. They don't. It's not as if only 15% are allowed to.
Right.
But and the rest go to good vocational schools or good schools that train them for
other.
And there's absolutely nothing wrong with it. And I would look. If people know why they want to go to university, then I'm in favor of it being open to everyone.
Right.
But universities are probably not the right place for a lot of kids.
Right.
A lot of kids, I think, and a lot of parents send their kids there just as sort of a rite of passage.
Exactly.
And I feel badly that kids come out after 4 years not knowing why they went in, because they don't get out of university what they should get.
With a huge loan too.
With a huge loan. But if you do that, it's a waste of your parents' money and a waste of your time.
Exactly.
Because university is a great place to go and expose yourself to knowledge independent of its practicality, and question your basic assumptions and learn about the wonderful, incredible legacy of intellectual gifts that have been given to us as human species. It's a wonderful place, and obviously I spent most of my life at universities, but you have to be ready to take that in, and you have to be willing to work hard to take it in.
Right.
And you can, and I still think everyone should have a basic level of literacy, and that's what we should be teaching in our schools. But a lot of people can have careers and successful careers without that. And what you really want to teach people, and this is true university or high school, what we really should be teaching is how to be a lifelong learner.
Exactly.
I know people who haven't gone to university, who are more well-read, more scholarly, and more intelligent than people that I know that have gone to university. It took me a while to realize that, because I was kind of academics have been my whole life, and it was only partly because of my public persona that I began to meet people outside of university and realize that
you're like, wow, this guy knows more than some other people.
this effete kind of pompous view I'd had that sort of the most intelligent people at universities was wrong. And so what we need, and it's also been clear to me in my own experience, I learned more physics. I certainly learned more about the kind of physics I do now after getting my PhD than before my PhD.
Really?
Yeah.
Wow.
And I think that's, for any good scientist, that's true. For any good scholar, it's true. We got to keep learning. But for humans, we got to keep learning.
Right.
And so our learning shouldn't stop in high school. Okay, what we need to teach people is how to teach themselves.
Right.
And that's what I'm talking about, especially in this world of fake news and social networking and access to information and misinformation. If we don't teach kids how to continue to access information appropriately and digest it and question it, then we're lost.
What do you say about people who think educating people about global warming or climate change is political in a way, because then when they grow up, they get to vote on policies that are against?
Well, look, they may or may not. The point is, arguing that we shouldn't educate people because they may come to conclusions upon being educated that disagree with our preconceived notions is child abuse. It's one of the things I argue. Some people argue we shouldn't teach kids evolution or science because it stops them believing in God. Well, it doesn't always, but if it does, okay, you'd rather your kids not be prepared to be part of an economy in the 21st century. You'd rather not learn the basics of modern biology in a world where biotechnology may be a great part of what keeps our economy going. You'd rather them be ignorant and believe something than learn something and perhaps change their mind.
Do you think
that's child abuse?
Do you think science and religion are compatible? Can a person be religious and absorb?
Well, the answer is yes, in the sense that I'm an empiricist, so I know scientists are religious. So obviously that's possible. But in my opinion, the reason they are that way is that people are, and by the way, this is a secret, scientists are people.
Really?
Yeah.
Let me write that down.
Yeah, write it down. News flash here, breaking news.
Yeah.
People are very good at believing two mutually contradictory ideas at the same time, because we're not purely rational human beings. As was once said, reason is the slave of passion. And so what is clear to me and most of my colleagues is that the tenets of the world's major religions are certainly incompatible with what we know about the empirical world. But people can as long as they don't let their religion influence their religious beliefs, have an impact on what they're doing in the laboratory, then it's perfectly fine. But
But I mean,
look. There are no miracles in the scientific world. There's nothing. There's no evidence of anything that violates known laws of science. If there are, then we're excited about it and we try and learn about it.
Right.
And so most of the world's religions are based on miracles. That's just one example. And it's certainly, science is completely inconsistent with a fundamentalist view, which namely means taking those scriptures, whatever religion, the Quran, the Bible, whatever, the New Testament, the Old Testament, taking them literally is clearly inconsistent with science. The earth isn't 6,000 years old, and there are people who say, I read the Bible, and the Bible says the earth is 6,000 years old, and the Bible can't be wrong, therefore everything we know in science must be wrong. And that's the wrong attitude, because science is, you can either...
Well, some people question carbon dating and how that's done.
Well, because they're looking for reasons to if you have the answer before you ask the questions, that's the wrong way of going about. What you have to do is ask the questions and accept whatever the answer is based on your investigation. So religious fundamentalism is saying, I know what's right before I know anything.
Right.
I know that this book must be right, and therefore everything else has to be consistent. Instead of asking yourself the question, let me look at nature and is it consistent? And if it isn't, then maybe I got to in fact, even...
That's a good point. You said, let's look at nature and see if the scientific method is using our senses, right?
Yeah.
Do you think there's phenomenon out there that it exists outside of our senses?
Well,
that is immeasurable through science, but still could be real or true?
That's the whole point of science. We've created instruments that allow us to see things that are beyond our senses. We have infrared detectors, microwave detectors, neutrino detectors, gravitational wave detectors. Right. We've expanded what we can detect. And that's revealed in an invisible universe, and that's part of what I try and say. Right. The real universe is so amazing, you don't need the nonsense.
Right.
The climate change is amazing. Some of the aspects of it are fascinating. The way the Earth works and the way it responds to things, the way the oceans work, it was fascinating for me to learn about. Okay,
and why is it the Catholic Church spent so much money on investing in astronomy? And one of the most important astronomers actually came from the Catholic Church.
Well,
if religion was opposed to...
he was excommunicated, though. I mean, they learned their lesson with Galileo. Right. I think there are a lot of reasons, and that I've read, and I'm not a historian of religion, that it's important. Some people would argue it was important for the Catholic Church to know what the real world worked, how it worked, so that they'd be prepared to deal with those people who'd somehow argue that disproved the existence of God. But when it comes to this religion and science thing, go back to St. Augustine, who's no scientist. Right. But what he once said was, and I'll paraphrase it, okay? Actually, Moses Maimonides, let me pick another person.
The Rambam.
And once said, look, the scriptures are absolutely true, he said. But if your interpretation of the scriptures disagrees with the evidence of science, you better re-examine your interpretation of the scriptures. And St. Augustine said that more or less the Bible isn't a scientific document. So bottom line is, if you think there's something profound in the Bible, that's okay. I don't. Let me make that clear.
You don't think it's poetic, at least?
Certain parts of it are poetic. Okay. Certain parts of it, and certain parts are boring.
Right.
There's wonderful poetry in the Bible. It's as a piece of literature, it's fascinating. Just like the Odyssey and the Aeneid are a fascinating piece of literature. But I don't believe in multi-headed beasts. Right. And from but I loved reading the Greek myths. Okay, so, but. What if you think it's profound in some way, that's fine, but you can't require the world. The universe isn't the way it is because you want it to be that way. The universe is the way it is whether you like it or not.
Right.
And whether or not you'd like there to be climate change, that doesn't matter. Whether or not you'd like humans to have an impact on the planet, that doesn't matter. And whether or not you think humans can ameliorate the problem doesn't matter. The question is, can we? Can we address this problem in a way that at least makes us better prepared? As in fact, as I end the book with a quote from Louis Pasteur, which is, "Fortune favors the prepared mind," and that's the important thing. We have to at least know what reality is if we want to respond as human beings. And my book is to say, here's the reality. Now let's have a discussion of policy. Right. Based on the reality, you can decide you want to do X, Y, or Z, and you can have rational debates about whether we need to immediately get rid of gas-burning cars, or whether we need to, institute a policy about electricity generation, or how to use nuclear power versus wind power versus
Right.
solar. All those things are important policy questions. But if we don't know the reality, we're just.
Do you think there should be a fundamental change in how society operates in terms of the people that lead us? Should there be scientists?
Well, no, I don't think science should lead us. I really
No?
don't. I believe in a democracy. At least I have.
yeah.
We'll see. But the point is, in a democracy, what we need are informed politicians and an informed public. Otherwise, a democracy doesn't work. So the
But
purpose of
the way
science is to advise, is to provide the data
Right.
that people who are rational and intelligent but may not be scientists can then assess that
Should there be a
information.
litmus test to see if someone's rational?
Well, that would be
And-
nice. That would remove most politicians.
Well, that's-
No, but I'll tell you my experience. I was an advisor to Obama during the campaign in 2008. I was he chose he made a group of 30 scientific people, a member of a community who were scientific advisors. But he had 30 committees of the best people that when I looked around in at least in the United States, advising on economic policy and science policy. And so to me, what you want in a good leader is not someone who knows everything. And there are some, maybe Thomas Jefferson, and Bill Clinton used to read voraciously too. But you want someone who recognizes, first of all, what they don't know, and secondly, how to choose really good people for advice. And then listen to good advice, okay, and assess, within the context of reality. Politicians have to realize that the questions of interest, and scientists have to realize, the questions of interest to politicians are not the same as the questions of interest to scientists. Scientists may say, as a scientist, it's obvious we do X, but politicians have to weigh different constituencies and may say, yes, the scientific guidance is this, but based on the readiness of the public to do this, or the economic priorities have here, I have to make that decision. So that's perfectly understandable that politicians, the priorities of politicians are different than the priorities of scientists. That's not a bad thing. That's just reality.
Right.
Scientists have to recognize it, and politicians have to recognize it. They shouldn't discount what scientists say because their advice may differ from what you want to do. They should realize that the scientists are telling you what's likely to happen, and if you want to do this, you have to decide what the consequences are. And so, I'm happy if more scientists go into politics. It's a shame that lots of lawyers or whatever, but
I know.
but I don't care. I don't care where people come from. I used to hire people at universities. There was a while when I was considering being a higher level administrative official at universities, and was invited to consider being a president and other things. But I've been on hiring committees and I'm often less interested in what the person's background is than what their capabilities are to adapt to new challenges. And that's really what's important for politicians and for society. So without an informed electorate and without informed legislators, then democracy fails. That's just it. And we're unfortunately in a situation where we're seeing the challenges to democracy, where information is not getting out. You have politicians who overtly, and this has always been the case at one level or another, overtly try and distort reality for whatever their personal reasons are. And that is possible in a democracy if you have a public who can see through that ultimately.
And the public won't be able to see through that if they're not educated, though.
What do you mean by educated? If they haven't learned how to tell the difference between sense and nonsense.
Yeah.
And that, I would say, is a scientific method. That's why science is important. Science isn't important because it's intrinsically more valuable than literature. It's important because it gives us tools to make predictions of the world that work, and to find out and find out which predictions don't work. It gives us a tool to assess the difference between sense and nonsense. And that's my mission in some sense. But it's not just pejorative. It also is wonderful. The reason I write books about climate change or Star Trek or whatever is because science should be a bigger part of our culture. Science has produced some of the most amazing.
Why do you think it's not a bigger part of our culture?
I think we've let this two cultures myth go on. We've let the myth that somehow you can be a cultured, intelligent person and not know anything about science. And that's why I love to have events and do things with people who are who are not traditional scientists. I loved,
Like like a Christopher Hitchens, very smart.
Yeah, Christopher Hitchens. I love doing.
Yeah.
I did a podcast with my friend Ricky Gervais, who's not traditionally known as a scientist. We talked about science, but or bring people like Brian May, who I did an event with, who's a guitarist for Queen, but also, by the way, happens to have a PhD in astrophysics.
Does he really?
Yeah, he was, and so we could talk about that. Or Alan Alda and I could talk about science, or Werner Herzog and I, and so.
So you want to make it more science to be more accessible.
Well, more accessible and I want to interest people. If people see that the people they're interested in are interested in science, maybe it'll be cooler.
Right.
And if the scientist is interested in science, it's not too surprising. But if a cultural icon is interested in science, then maybe it's not. That's why I love to interact, and I love to bring together science and culture. And I think, in some sense, climate change is a cultural issue.
It is.
But I want to bring to and so the book isn't all just like it's the physics Star Trek wasn't this won't work, that wouldn't end any fun. This isn't all doom and gloom. This is a fascinating way of understanding how the world works. And it doesn't have to all be all bad. It's fascinating to learn how the Earth works and how it responds.
I think that's what people's impression are when they talk about climate change or global warming. They have like a negative kind of connotation to it. They're kind of like,
because it's scary.
Does that mean I have to pay someone for my carbon offset? And that's where they start to contemplate.
Well, it's all been expressed in terms of doom and gloom and things you can't do, and that people don't want to hear about that. Okay, and I think, and I've seen it to some extent in this political campaign. What we need to do is point out, hey, there are opportunities and challenges that we can. For example, the United States has had an awful power distribution system in our country. We really need to fix it, independent of anything else.
Right.
To be able to get electricity from one part, from where it's produced to where it's being used, and to use it rationally. Well, addressing climate change can allow us to develop an infrastructure that does that. In the end, we become better off independent of that. Right. We have more reliable sources of energy 24 hours a day. So in the hot days of summer, in one place, we don't run out of power and have to turn.
Kind of like load balancing.
Yeah, and so I think you're right. Climate change, it's like nuclear weapons, which is another area I've spent a lot of time on. And I was chairman of the board of the Bolton Atomic Scientists for years and helped set the doomsday clock.
When I was in elementary school, they told me that in 10 years there's going to be a nuclear site, like in every neighborhood. That's what I was told when I was a kid. And now there isn't anything like that. But it's this doom and gloom thing.
Oh yeah, well, exactly.
It's pervasive in all these different...
And people don't want to hear it.
Right.
So whenever I've written about nuclear weapons, which we need to deal with, and their reality, whether we like it or not, falls like a, flat. The least response, when I've written in the New York Times, as I used to, or any other place, those op-ed pieces would have the least response because people don't want to think about the fact that nuclear weapons can destroy our civilization like that. Right. It doesn't mean they have to, but if we don't think about it, then we're really in peril. Right. But climate change isn't like nuclear weapons. It's an existential threat at the same level, but happily, it's something. Nuclear weapons, in order to deal with, we need sane politicians who are willing to act. That's
back to the same thing.
Yeah. But that's a lot harder. Climate change is an area where the public can actually have an impact. The public can only have an impact on nuclear weapons if they protest en masse and say we want to treat. But by our actions,
what can we do as individuals to stop or slow it?
Well, and that's part of the problem. Everyone looks around and says, "How can I do anything?
What can I do?
Yeah. Why should I do anything? What I do isn't going to be important." It's like, why people have large families. They don't realize that the population of the Earth is a big part of the problem. In fact, sure, it's a big part of the problem. If we didn't have 7 billion people, if we didn't have 10 billion people in 2050, that 10 billion people is a lot bigger strain on the resource of the Earth than 7 billion or 3 billion as they were when I was younger. Absolutely, population is part of the problem.
Yeah, but then that brings up all these ideas about population control and this whole thing, and then goes back to another negative kind of
thing. I know, but on the other hand, you don't have to do that, because I think generally, and this is one of the reasons I wrote many years ago an article for Scientific American saying educate women, save the world, because when women are more educated, they have fewer children. Do they? I'm talking about in third world countries, absolutely, because they realize what the how the well-being of their family partly depends upon that, and they're also more capable and empowered to control their own reproductive cycles. And so, but I think that how people individually can affect things is, first of all, the first thing you do is learn enough to be responsible and vote the right way. That's not a non-trivial thing. Learning enough to be able to vote for politicians who produce policies that might produce rational actions.
Climate change is political at the end, right?
Well,
in a way.
Everything we do is political.
Right.
But that doesn't mean science is political.
Right.
But science affects our political decisions.
Right.
And that's okay. That's a good thing. Just like economics should affect in some level our political decisions. And art should affect our political decisions, at least decisions on what we make about how to support the arts and music in the schools.
Right.
But there's lots of little things you can do. One thing I would say, and this wasn't easy for me, but I don't eat meat anymore.
Really?
Okay. Yeah, because meat is a huge, because the amount of resources we take to not just from the point of view of how much wheat and corn could be used to feed people around the world that's used to feed cattle, but the actual carbon footprint is huge. And so it's a simple thing to do. Well, it's not that simple, but you can do it.
How long have you not eaten meat for?
Just actually, by the way, just this year, since in January, when I began to seriously think about this issue. I've been thinking about it for on and off. I've done events with my friend Peter Singer, who's famous for writing about animal rights, and I've sort of eaten meat guiltily for years. My daughter's a vegetarian.
Really?
But I finally decided, let's just see if I can do it.
So a hamburger is really not
No, and it's not as if I hate it, but I can do fine without it.
Right.
And so that's one kind of thing you can do. But the other thing I think that we can do, each of us can do, and it may seem, look, I just voted here because happily in Oregon we have voting by mail. We've had it that way ever since I've been here. It's no big deal. Often when I vote, I kind of feel helpless because I think, well, my vote means, it's so little.
Right.
But those votes add up and have an impact. So even though my vote for president feels, ineffectual because that doesn't see it, eventually these things have an impact.
It adds up.
And I think that I really do think that if people are asking what can they do, is they can inform themselves. And that helps affect their own decisions and the decisions politically that they act on.
So, don't eat meat.
Well, that's one thing.
Don't have kids.
Not don't have kids. You to decide. You have to. Look. These. I'm not proscribing things or prescribing.
Suggestions.
I'm saying you have to decide where your priorities are.
Right.
Okay. If you do one thing, maybe you give up on another. You have to decide. You have to know what the consequences of your actions are going to be. You think having a big family is important to you, and fine. Realize the consequences of that, and maybe you take other actions to make up for it. If you want to, if you feel responsible to balance those issues, but so you don't have to give up what you want to do. So you just have to realize that you have to take responsibility for your actions.
So I've always thought when smart people or educated people don't have kids, how are we going to replace the earth with smarter people?
Well, that's what you have. That's
conundrum.
Yeah. Well, look, that's kind of but that's a misunderstanding in some sense, I think, happily, of how genetics really works. That somehow only the children of educated people are intelligent.
Not always, but
no. There's a ton of example. I mean, not that it matters, but neither of my parents finished high school. Okay, and so I think the wonderful thing.
It doesn't mean they weren't smart, though.
Yeah, but who am I to decide who's intrinsically smarter? Once again, I told you that you can't always look to people in universities to find the most creative, most intelligent people around. Right. And so the great thing about the mixing of genes that comes from sexual reproduction is that you get diamonds in the rough. And I think that the people who are more educated aren't having enough kids. They've got to have more kids because the people who are less educated are having a lot of kids. But I do think what we really want to do, I'm more concerned that people who may not be as educated are having more children because it keeps them in poverty. That concerns me more than anything, is that realizing that in some sense they're dooming themselves and to some extent their children to a future that may not be as good. That concerns me much more, especially in the third world.